Okay, so we are on the third part of the book that talks about the equations of motion. And then this is general equations of motion. But this is not different than the Newton's second law. The first is that assume that we have a rigid body with different forces like F1, F2, F3, F4, and in different directions. In addition, we have the moments, we have the weight of the body, and then we have the center of mass of the body. Then we will write equations of motion. The forces in x direction will be mass into acceleration with acceleration of the center of the mass of the body. Similarly, y direction, and similarly the moment, and that will be the moment of inertia. If you remember the I, moment of inertia with respect to g, so the axis passing through point g, and then into the angular acceleration alpha. You see, that is the same as Newton's second law for a particle. Instead of particle, now we take the g. But if you take any point other than g, so any point other than g, then you will use this equation for this one. Okay, y bar, that will be the distance from here to that position, g. That's the y bar. And then x bar is distance from here to there. And then the mass into acceleration, and then this final formula. Okay, if it is pure translation, then you see that this term, so there is a rotational equilibrium, or the angular acceleration is 0. Okay, then we will use this same equation with only difference that we will have only two terms. Okay, moment will be 0. If it is for this one, it is a rectilinear translation. The body moves, this is the rigid body. It moves along a straight line path with a center of mass having an acceleration of m into ag. What if you have a curvilinear path? In the curvilinear path, you will have a tangential and then normal acceleration. And then for this tangential and normal acceleration, again, the same principle, t and then n, we have instead of x and then y. Center of mass moves with acceleration of agt, in normal direction agn, and then this is the equations of motion that you will apply. If you take any point other than g, then you will use this equation. And then E value is the distance between the B and then center of mass. H is the distance between B and then center of mass in tangential direction. This one is in normal direction. Okay, that is exactly the same as this one. The only difference being is that you are using the normal and then tangential acceleration instead of the x and then y coordinates. That's all for this introductory part of these equations of motion. Then we will solve problems on this.